Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. In today's video, we are solving this P3 paper. And this P3 paper is of October-November 2024, variant 33. So now let's look at the question first and then look at the solution. So now question number 1 is about complex number. The complex number z satisfies z modulus equals to 2. We know that this is a circle. An argument of z lies between 0 and pi by 4. These are two half lines. On the Argand diagram below, sketch the locus of points. Locus of points representing this, they're asking for sketch, not the shading. So if you do shading, that would be marked as wrong. The second one, on the same diagram, sketch the locus of points representing z square. 2 marks for this, 2 marks for this. So now let's look at the solution. This is z minus 0 plus 0I modulus equals to 2. It's a circle. Center is the origin. Radius is 2. That is the red circle over here. And then it says argument of z lies between 0 and pi by 4. Half line is starting from 0, 0. And there are two half lines. This is at 0 radians. This is at pi by 4 radians. So now over here, if we are not shading, what exactly are we doing? We are looking for the region. We are looking for the arc. So over here, let me grab an eraser and let me erase this thing for a second. Standard eraser. Let me erase this thing. And let me erase this thing. Okay. So now basically, this is what is required from us. And let me also erase this thing. So now this arc is what we are looking for. So now this arc is the two half lines and part of the circle between the two. So we don't have to shade it. That is the answer. Sketch the locus of points representing z. So this could be the arc and these are the two half lines. So it's between the two half lines and the modulus is this arc over here. Now it says on the same diagram, sketch the locus of point z square. Modulus of z is 2. Modulus of z square is modulus of z squared, which comes out to be 4. Argument of z is 0. Argument of z squared, 2 times argument of z. So these are the properties of modulus argument form regarding multiplication, division, and power rule. Argument of z squared, it's 2 times argument of z. 2 times 0 is 0. 2 times pi by 4 is pi by 2. Same shape, new radius, new angle. So now this is the big circle that we have drawn. And now the angles are such and such. Let me use a green marker for this one. So over here, this is that 0 thing all the way up till here. Let me grab this thing. And this is 0 till pi by 2 like this. And let me erase the extra stuff all the way over here like this. So now this is z squared that is going from here to here. That is z squared. Let's also go to the mark scheme. And that's the first question over here. So they have drawn the arc. The arc is the colored thing. They have drawn the arc. For all 4 mark scales must be approximately equal. Dashes can replace number. Arcs don't have to be perfectly circular. Mark intention. Show an arc of a circle, center, origin, radius 2. Only need 2 on real part, 2i on imaginary part. Show an arc, center, origin, such and such. And mark B1 if sector shaded. So that means 1 mark will be lost. Maximum B1 if vector is shaded. So there are 2 parts. 1 mark will be given, 1 mark not. Show an arc of a circle, center, origin, radius 4. Only need 4 on real and 4i on imaginary. Basically radius 4. Show an arc of a circle, such and such. So the green one is the thing. Let me go back over here. And there is the thing. So over here, that was the small arc over here. So let me just use this precision eraser. That is the small red arc that was over here. And over here, this is the purple arc. So the first part is the red arc. The second part is the purple arc. Next one. Question number 2. Let fx is equals to such and such. Show that if a sequence of values given by the iterative formula converges, then it converges to root of equation in part 1. Basically, this is equation. This is iterative formula. Equate this to this or equate this to this. Doesn't make a difference. Then it says the equation has a root close to 1.2. Use an iterative formula for part A, initial value 1.2, determine the root, correct to 2 dp, give the result of each iteration to 4 dp. So now the first thing, I just erase n plus 1 and n, because in iterative formula, you have this thing written. When you remove this, this equals to this. After successful iteration, the input and the output is the same. Square both sides, cross multiply, and this is what you get. X1 is 1.2. X2, you plug it in over here, you get 1.2403. This is 4 dp. You plug this value over here, you get this value. You plug in this value over here, you get this value. The numbers are getting closer. 1.24 to 1.26 to 1.27 to 1.275 to 1.2779. Now, these two are very, very close. This one rounds off to 1.26. This one rounds off to 1.26. Therefore, stop over here. The root of the equation is 1.26, correct to 2 decimal places. So this thing is done. Question number 3, a linear law question. The number of bacteria in population P at time t hours is modeled by this equation, where A and K are constant. The graph of ln P against T is shown in the diagram. It has a gradient and intersects the vertical axis as such and such. So instead of giving you the points and making you find the gradient yourself, they have already given it as such. State the value of K, find the value of A, correct to 2 significant figures. Find the time taken for P to double, give your answer correct to the nearest R. Coordinate geometry, this part is already done. So coordinate geometry is done. Y-intercept is 3, gradient is 1 over 20. The logs part, take ln of both sides. So therefore, ln P is ln A, and this is kt ln of E. So this is your Y, this is your X, this is your C, and this is your M. So now this C is equals to ln of A. And C is 3. ln of A is 3. A is e raised to power of 3. Similarly, M is equals to K. So therefore, K is 1 over 20. So therefore, M is 1 over 20. So let me write over here. Therefore, M is 1 over 20. And they are asking A, K is exact, and A is e raised to power of 3. So let me grab my calculator. I left it in the exact form. So now this is shift and E and raised to power of 3. So that is 20.08. So this is 20.085, and it says 2 significant figures. So therefore, this should be 20. Let's double check the answer from here, wherever, whenever it is needed. So over here, this is 20 over here. And now the second part is left. So now they are paying a lot of emphasis on the significant figures and all these things. Find the time taken for P to double. When T is 0, P is A. Even though I have the value of A, I'm not plugging it in. T is unknown, P is 2A, because the ratio would be the same. Whatever is the value of A, I'll write 2A over here. So after division, this will come out to be 2. Take natural log of both sides. Therefore, T is ln2 over K. This has to do something with half-life, those who study physics. And ln2 divided by K, K is 1 over 20, divide. This is ln2 raised to power of 20, 13.862. It has to be given to the nearest R, nearest unit, that's 14 hours. Find the complex number Z satisfying this equation. Now, a lot of people think that in order to rationalize a mistake, what they make is that in order to rationalize Z minus 3i, Z plus 3i, and Z minus 3i, Z minus 3i. This is totally wrong. Because this is not, this Z is itself a complex number. This is not 4 plus 3i. This is Z plus 3i. Z has this thing in it. Now, first thing, if someone wants to rationalize, I'll write X plus yi or iy plus 3i. That is x plus y plus 3i. And then I will write x plus iy minus 3y divided by x plus y plus 3i. Now, when we rationalize, we can do it like this. That is x plus y plus 3i and x plus x minus, actually, the sign changes. So this is x minus y plus 3i. So if someone wants to do it using the method of rationalization, now this is the correct way of doing it. And then you would equate it to this thing and you would solve, but I have not done it using rationalization. I simply cross multiplied. So I cross multiplied, this multiplies with this multiplies with this. I open up the bracket and I isolate the z. This is 7i plus 9 over 1 plus 3i. I simplified it also, dividing by 3. Now this is rationalization. I get z as minus 2i plus 3, which is 3 minus 2i. That is z from here. Pretty basic. Just have a good look at the question. Now the next one, question number 5. It says cos power 4 theta minus sine power 4 theta minus 4 sine square cos square theta is this much. Now over here, we need the double angle formula. Cos 2 theta is cos square minus sine square. Sine 2 theta is 2 sine theta cos theta. We also need this thing, which is over here. That is factorization. That is a square minus b square. That is a plus b, a minus b. We also need this concept a4 minus b4, a power 4 minus b power 4. That is a square plus b square, a square minus b square. And we also need indices. That is 4x square, y square. That's the same thing as 2xy, the whole thing square. So now look at all of these things. Where have we applied which concept over here? So now over here, let's just hold for a second. There is some technical issue. So now let's continue with this. First of all, the factorization is the blue part. So let me grab the highlighter. This factorization, a square plus b square, a square minus b square. This is the mother of all identities. Sine square plus cos square equals to 1. And we are left with this. And this green thing is over here. That is 2 sine theta cos theta whole square. 2 sine theta cos theta becomes sine 2 theta whole square. And the blue thing becomes this thing, that is cos 2 theta. That is from here. Got the idea? So now this thing is done. Now the only thing that is left is that when we say sine square x plus cos square x equals to 1, sine square x plus cos square x equals to 1, this can be written as theta theta. This can be written as 2x also. So sine square 2 theta is the same thing as 1 minus cos square 2 theta. And then we get this equation right over here. And we have proven it. So we started with the left-hand side and we have proven it to the right-hand side. How many marks is this? 4, I think. 3 marks. All good. The next one, solve this equation. So now it's the same equation as above, except for the fact that theta is replaced with alpha. So now we have this thing, cos square 2 alpha, cos 2 alpha minus 1 equals to 0. This is a quadratic in terms of cos. So this is a quadratic in terms of cos. In terms of x, it's in terms of cos x. So therefore, cosine 2 alpha equals to this. Actually, it is in terms of cos 2x. So this cosine 2 alpha, I have evaluated b square minus 4ac separately. And then I have minus b plus minus b square minus 4ac divided by 2a. Negative 1, negative this thing. This is greater than 1. Cos 2 alpha lies between negative 1 and 1. That is the reason it has no solution. Cos 2 alpha is positive. Therefore, it's in the first and the fourth quadrant. Modify the range. Range is between 0 and 180 inclusive. 2 alpha lies between 0 and 360 inclusive. Basic angle, I use the symbol beta for this because alpha was already occupied. I got the answer in 2 decimal places. This is first quadrant. This is fourth quadrant. Final answer after dividing by 2 and taking care of the accuracy, that is this thing. Question number 6. The two lines have the equations L and M. They intersect at point P. State the coordinates of P. For the first time, I've seen such a basic but challenging question. Without making you solve, they're asking for the point of intersection. Focus on the fixed point, 2, 1, minus 3, 2, 1, minus 3. This is common. So the common point is the point of intersection. So the common point is the point of intersection. Find the exact value of the cosine of the acute angle. So use the direction vector, find cosine. Rather than the angle, the cosine. Now, first, let's look at these parts. And there is also a very nice third part also. Fixed point is the same, common. That is point of intersection. If they ask for position vector, so if they ask for position vector, we write it like this. If they ask for coordinate, we write it like this. Direction vector 1, let me do some highlighting. Direction vector 1, magnitude of direction vector 1. Direction vector 2, magnitude of direction vector 2. So this is direction vector 2, direction vector 2, direction vector 1, direction vector 1. And then you make cos theta the subject. The numerator is positive. That means the angle is acute. So now there are two ways of rationalization. Let me also show you this one. 8 over root 150, multiply with root 150, multiply and divide with root 150. So this is 8 over 150 into root 150. And then you can break this 150 as 25 into 5. 25 into 5. And this is 8 over 150. And naturally, it would simplify to this. Over here, I have broken up root 150 as root 5, root 5, root 6. Root 5 becomes 5. And then I rationalized it. Got it? So now I'm interested in this one because this is the simple one for the next part. So that is how you find cosine. Part C, the point A on line L has coordinates such and such. So A lies on L and B lies on M. Hold for a second, lies on M. So this is another line, this is another line. Find the exact area. Now we know that these two are meeting at point P, correct? So let me just give you some idea. So this is one line like this. This is another line like this. And this is where they're meeting. This is P over here. This is A over here. This is B over here. And it says find the exact area of this triangle. So we have this cosine of this angle APB. There it is. We took two vectors and A is like line L and B is like line M. So we got this angle between the two lines. Of course, we have the cosine. We can find this distance. We can find this distance and use the formula half AB sine C. Got the idea? So over here, we have OA, we have OP, we found PA, we found PA modulus. So again, another usage of kind of not the dot product as such, but basically the magnitude. And then we have OB, we have OP, we have PB, we have PB magnitude. So now look at the working. Now this is the most important one where people get stuck. That is why they put a lot of emphasis in P1 on the exact ratios. Cosine is 8 over root 50. This is adjacent. This is hypotenuse. Therefore, the height or the opposite side is h. I find it using Pythagoras theorem. Leave the answer in the exact form. Area of triangle half AB sine C, half into root 20 into root 30 into root 86 over 150. I took the square root common out. 20 into 30 divided by 150, that is 4. And square root of 4 is 2. Square root of 86 is square root of 86. 2 cancels out. I'm left with root 86. They are asking the exact area. That's how this is to be done. A very nice question. So now let me just write over here. There was one question like this again in 2024. Check that out. So 2024 has questions like these in which they were talking about area of triangle, or maybe 23, area of triangle and area of parallelogram based upon vectors. So this is one of my favorite questions and focus on such questions. Question number 7. It says the parametric equations of a curve are such and such. Show that dy by dx is this much for 5 marks. Now, this differentiation was not tough, but lengthy. It was lengthy. The x1 was too easy. Dx by d theta, that is 3 into 2 cos 2t. That is 6 cos 2t. And this is for later on. This is for later on. There were different options for this. I can write sine, a tangent as sine over cos, and then cos as cos over sine, and then work it out, but it was getting messy. So I wrote tangent as tangent. I wrote cot as 1 over tan t. Then I took it up. Tangent t, direct differentiation. Tangent t, this is chain rule. -1, tangent, -2, derivative of bracket. Then I took sec squared t common out. So let me highlight this. I took sec squared t common out. That goes on the outside. And I'm left with all these things on the inside. And then I converted into sine square over cos square. That becomes this thing. Then I open up the bracket. So sec square is 1 over cos square, 1 over cos square, 1 over cos square. And I don't open up the bracket. I just take LCM on the inside. So when I take LCM on the inside, that is sine square minus cos square over sine square. And then I suddenly realize double angle formula. So if I take -1 common out, that is cos square minus sine square over this thing, which is sine square, and this thing, which is cos square. Keep that in mind. Similarly, over here, what I can do is that cos 2t can be written as cos square t minus sine square t. And then I realize something needs to be cancelled out. So dy by dx is dy by dt divided by dx by dt. So this is dx by dt. That is, I think, wrong color. So this is dy by dt. That is over here. That is over here with the minus sign. And this is dx by dt. That is this thing. Division by dx by dt is multiplication by 1 over this. Now look at the working. Again, there is a lot of emphasis on double angle formula, as you can see in this particular paper. So over here, the double angle thing again springs back to action. That is sine 2t is 2 sine t cos t. Therefore, half sine 2t is sine t cos t. And then half sine 2t whole square, when you square it, that is 1/4 sine square 2t. This is after squaring. Got it? So this is what you're getting, and this becomes 2, and this becomes 3, and that is the exact answer that is written over here. The next one, that was very basic. Find the equation of the normal to the curve at the point where t is this much. Give your answer in the form. So a y term, and then an x term, and then a constant, right-hand side is 0. So t is pi by 4, and you get this thing. So t is pi by 4, you get x. X comes out to be 3. Y comes out to be 2. dy by dx is coming out to be -2/3, which is gradient of the tangent. Therefore, gradient of the normal is the negative reciprocal. We already have the points that is right over here, 3, 2. So y minus y1 is equals to mx minus x1. Simplify, and this is what you get. So that was very, very basic stuff. So 3 marks for the basic stuff and 5 marks for the stuff. So sometimes part 1 could be hard also. Question number 7. That was also a nice question of partial fraction working in terms of symbols. 7a squared. Let me just check one thing. All good, all clear. So now this is 7a squared. That's a constant. A minus 2x, 3a plus x. X is a variable. A linear, a case, denominator with linear factors, b over something, c over something. I deliberately did not use a because small a was there already. So b and c. After LCM and everything, the numerator equals to this into this, this into this. Let x is equals to -3a. I'm taking this to be -3a so that b becomes 0. I find the value of c, that is in terms of a. I plug the value of b over here. I plug the value of c over here. So hold for a second. I found c over here. C is a. So this c is now replaced with a. And now I'm focusing on b. I could have plugged in this equation. That is a minus 2x equals to 0. 2x is equals to a. X is half a. That is also one option. But what I did was that I plugged in the value. And then I used a simple value, which is 0. So I got the value of b, which is 2a. So B is 2A and C is A over this thing. So it's in terms of A. A is a constant. Now, what is the next part? Hence, obtain fx in ascending powers of x up to and including the term in x squared. So now what you need to do is that take this up, and make the first term 1. So remember, this is 1 plus b raised to power of n. Let me make the marker thicker. That is 1 n b power 1 over 1 factorial n minus 1 b power 2 over 2 factorial and so on. So over here, the first thing first, the red thing over here. So let me focus on the red one. That is a minus 2x raised to power of -1. Take this a common out. And over here, the whole thing is raised to power of -1. So a raised to power of -1 is 1 over a. And then you expand this thing all the way over here. The first term, the second term, the third term. Look at all the steps. You get this thing on the inside, you multiply it out, you get this thing. There are 3 terms that you're getting. I'll just highlight them a little bit later. Similarly, the blue one, a as it is, and 3a plus x raised to power of -1. That is 3a raised to power of -1. Naturally, the bracket is raised to power of -1. That is 3 over a. That becomes 1/3. And over here, 2a over a, that became 2. So that became 2, and so on. So now again, the blue thing, that is the first term, and then the second, and then the third term. Simplify everything. 1/3 is there waiting on the outside, and these are the 3 terms you are getting. So now let me choose 3 colors. I need to add them up because there is a plus sign in the middle. So therefore, let me minimize it. This 2 will be added to 1/3. And this 4 over a, the x term, should be added to -1 over 9a. And then the third part, the orange 8 over a square, will be added to 1 over 27a square. So just double check. 1 over 27a square and 8 over a square, that gets added up. The purple one, 4 over a minus 1 over 9a. And then the green one, which one is that? That is 2 and 1/3. So you get this thing. And then you get the purple thing, and then you get the orange thing. So this is like kind of boring stuff of P3. So 4 marks for this. Got it? One last part over here. It says state the set of values. This is very important. Very, very important. State the set of values of x for which the expansion is valid. So now the rule is, when we have 1 plus b raised to power of n, where n could be a negative integer or n could be a fraction, the series is infinite. So understand the logic a bit. Series is infinite, but its sum will be finite. Will be finite if modulus of b is less than 1. So that's a rule. Just like GP, sum to infinity. A common ratio modulus less than 1, an infinite series has a finite sum. That is the logic right over here. So now we have this thing. Let me use the red marker again. This is minus, and this is 2x over a. And this 2x over a modulus is less than 1. Doesn't make a difference if there is a negative sign. The modulus will make it disappear. Therefore, x modulus lies between half a. And I can write it further. Therefore, x lies between half a and -half a. And similarly, over here, let me just move this thing up. Let me just erase this thing because I've already written this thing. So let me choose the stroke eraser. And like this goes up like this. And over here, let me write this thing. Therefore, x lies between 3a and -3a. So this is the blue one over here. X over 3a modulus is less than 1, and x modulus is less than 3. So therefore, x lies between such and such. So this is the blue one. This is the red one. Shown it on a number line. That's the red one. And that is the blue one. So let me just change it into blue color. and we pick the common region. So this is the common region that's right over here. So common region is the final answer. That is how this thing is done for 1 mark, but of course you have to do it. Find the quotient and remainder when this quartic is divided by quadratic. So quartic, there is x4, there is 0x cubed, 0x squared, 0x plus 16. It's divided with x squared plus 4. Take the highest power, divide, that is x squared, multiply with both of them, write it down in their respective places. Change the sign and add. Change the sign and add. Then again play with two terms. So you have to take all the way down till the constant. And then again, negative 4x squared over x squared, that's negative 4. Again, write it down, change the sign, and this thing is done. So we have a quotient, we have a remainder, we have a divisor. Divisor is there naturally, that is x squared plus 4. X squared plus 4, that is the divisor. So now what are they asking? They are asking, hence show that integration of this for 5 marks between these two limits is this much. Now over here, this thing over here, x power 4 plus 16 over x squared plus 4, what is it? This is quotient, this is remainder, this is divisor. Basic integration, this involves what? The tan inverse. X squared plus 2 squared. So make sure that you write it separately and double check. 1 over x squared plus 2 squared dx, that is 1 over 2 tangent inverse x over 2 plus c. So this is 4 is 2 squared. So this is 1 over 2 tan inverse x over 2. Of course, there is no c because there is limits. You plug in the upper limit. You plug in the lower limit. You simplify with the surds and everything. Have a good look at it. How has the simplification taken place? Of course, indices is the heart and soul of math. Cannot skip indices, cannot skip exact form. So now it's in terms of pi and fractions. It's good that the surds cancels out. Otherwise, we would be having surds also. Question number 10. A water tank in the shape of a cuboid. Well, I love differential equation, so I'll keep it for last. Hold for a second. Let me go to this differentiation first, and then I'll come back. The diagram shows the curve and its minimum point M, where x is equals to a. Find the value of a correct to 2 decimal places. Now, you see a turning point over here. You see a turning point over here. So we would choose the one that lies between this and this. Pi is 3.142. 2 pi is 6.284. So keep that in mind, that choose between these two. Of course, you have to do differentiation. You have to do product rule. Y is equals to uv. Therefore, y prime is uv prime plus vu prime. That is the first thing. Let's have a look. So u is equals to 2 sin x. U prime is 2 cos x. V is 2 plus cos x raised to power of half. Chain rule, half, bracket remains as it is. Power reduces by 1 into derivative of bracket. So this is u into v prime. So 2 into half into negative sin x into the square root. So 2 and 2 should cancel out. Negative sine square x. I'll just write it down. Right now, this is negative sine square. And this is 1 over, this is power minus half. So 1 over 2 plus cos x. So that minus is there. Let me just focus on it so that people don't forget. Yes, the minus is there. And this 2 and this 2 cancels out. And this is this into this. That is 2 plus cos x raised to power of half. That is this thing into 2 cos x into 2 cos x. All good? Now, if I make it equal to 0, I'll transfer this to the other side. This minus and this minus cancels out. So let me write it over here. I wrote a minus, and then I cancel out. Now over here, again, indices and surds, root a equals to a. So therefore, over here, this is root 2 plus cos x. This is root 2 plus cos x. That is simply 2 plus cos x because the thing on the inside is the same. And then this is 2 cos x. That's right over here. And this thing is sine square x. That is right over here. This is sine into sine. That is sine square x. All good? So now we make a single quadratic equation. Again, we find b squared minus 4ac. This is quadratic in terms of cos. Quadratic in terms of cos. I think in the beginning we solved a question in which it was in terms of cos 2 alpha. Too much of cosine, too much of quadratics. We get two answers. This is exceeding -1 and +1. It's out of the range. So discard. Since cosine x lies between -1 and +1, that is the logic. Now focus on this. Cosine x is this thing. Basic angle, you always calculate it with the positive ratio. This comes out to be 4 significant figures. They are asking decimal places this time. I work in significant figures. In the end, I'll take care of it. So that is the first quadrant. That is the fourth quadrant. This is 1.35. This is 4.93. This is 3 significant figure, but 2 decimal places. Look at the diagram. So it lies between pi and 2 pi. Pi is 3.142, 6.284. Does it lie in this interval? So therefore choose x is equals to 4.93, and that is the value of a. They're only asking for the x coordinate. They're not asking the y coordinate, the only x coordinate, because that is a. So now people, let's look at the second part. It says use the substitution, find the exact area of the shaded region. The shaded region is R. It is between 0 and pi. You have to integrate this equation. So integrate sine x 2 plus cos x square root dx between limit 0 and pi. I took this 2 on the outside. First thing first, let's get started with each one of them. First of all, always differentiate. U is 2 plus cos x. Therefore, du is negative sine x dx. Therefore, negative du is sine x dx. Focus on this. Sine x dx is negative du. That is the first thing. Next thing, 2 plus cos x is u. So root 2 plus cos x is root u. That is simple. That's right over here. Third thing, that is the limits. The original limits for variable x are 0 and pi. This is 0, this is pi. 0 becomes 3, pi becomes 1. Place limits where they belong. So 0 is giving me 3, it goes down. And pi is giving me 1, it goes up. Don't worry about which one is greater, which one is lesser. That's not your concern. Everything will be settled down. So now I remove this negative sign and 1 goes down, 3 goes up. It's all done. So now this is plus and the change has taken place. So this change over here, that is this plus, and these two have changed places. Now it's very basic integration. Root u power half over half plus 1 over half plus 1. Division by 3 over 2 is multiplication by 2/3. That becomes this much. Upper limit, lower limit. So now plug in the upper limit. That is 3. That goes over here. Plug in the lower limit, which is 1. That goes over here. 1 to any power would remain as 1. And 3 raised to power of 3 over 2. That is root 3. That is this one. Root 3 raised to power of 3. Root 3, root 3, root 3. 2 root 3's becomes 3, and this is root 3. So this is 3 root 3. This is the same orange one, and just open up the bracket, and that is the final answer for this one. So now let me go back up, and there is this my favorite question of differential equations. So now it says a water tank in the shape of a cuboid with a base area. It's a cuboid. Base area 40,000 centimeter cube. At time t minutes, the depth of water in the tank is h. So volume of water in the tank is base area into height, that is 40,000 h. And then you find this thing, dv by dh is 40,000. That is the first thing. And then the next thing, it says water is pumped into the tank. So this is into at a rate of this much. Water is leaking out of the tank through a hole at a rate of such and such. So therefore, the net rate of flow of water in the tank is inflow minus outflow. So this is inflow minus outflow. Remember this rule, dv by dt, that is inflow minus outflow. We have seen questions in the past in which they have said that this is proportional to h. So therefore, this is k into h, something like this. So this is an easy version of that. And then the third part, what are we focusing on? So dv by dt is right over here. dv by dh is this pink one. And the blue one is dh by dt. So make dh by dt the subject. So therefore, the pink one goes at the top. Actually, the green one goes at the top. That is this thing, 50,000 minus 600 each. And the pink one goes at the bottom. That is 40,000. So now look at the answer. How much have they simplified? They could have worked in decimals and so on. They have 250, they have 200, they have 3 each. So 600 has become 3. Therefore, it's division by 20. Got it? So therefore, a division by 200. So therefore, 600 over 200 is 3. So take 200 common out from the top, 200 common out from the bottom, cancel it. 200 cross multiply, 200 dH by dt is 250 minus 3h. And that is what you were out to prove. So that is for 3 marks. Next one. It is given that T is 0, H is 50. Find the time taken for the depth of water to reach 80 centimeter. Give your answer correct to 2 significant figures. Just check everything is in centimeters. Yes, everything is all balanced. So now they did not mention what to make the subject. So I could have made T the subject. I could have made H the subject since they're asking for T. And maybe that is the practical thing. I made 1 dt on the left-hand side and dH into all this thing on the right-hand side. Now, which integration technique is used up over here? That is 1 over, hold for a second, first let me write like this. This is 1 over ax plus b dx. That is 1 over a ln ax plus b plus a constant of integration c. So the coefficient of this variable is -3. That's why you get a -3 over here. And then it's ln 250 minus 3h plus c. Then you plugged in the condition. C comes out to be this thing, 200 over 3 ln 100. Now rewrite the equation. So now this is the particular solution. This is particular solution. They are not asking us to make T the subject as such. Well, it's already the subject. But they are asking us the time taken for the depth to reach 80. So now plug in H is equals to 80. So therefore, 100, 3 into 80, that is 240, 250 minus 240, that is 10. So 100 over 10 with an ln, that becomes ln 10. Use a calculator. This is what you're getting. We want the answer in 2 significant figures. So that is the answer. So October, November 2024, variant 33, done and dusted. February, March 2025, variant 32 was already done before. So signing off for P3 for this particular academic year. And there will be a live session tonight. Inshallah, it will be at 7:30 p.m. Pakistan Standard Time. That is GMT +5. Take care, everyone. Stay tuned for more content on Mathematics with Shahab Yaqub.